questions do we have that we want to go over? You can name it by page number and then what problem number, Sarah?
Page 1, number 2.
Number 2. Okay, so this one. So 10a to the 5th to the negative 2nd power. Now let's try to remember what is that negative power going to do to this expression? It's going to flip it over, right? So when I go to do 10 to the negative 2, that's not going to be a negative number, right? That's not 10 squared and then make it negative. That's 10 squared and then put it on the bottom of a fraction. So that would be a 100 down on the bottom, okay? And then what do I do to combine these exponents? When you're raising a power to a power, you multiply. Okay, power to a power, you multiply. So 5 times negative 2 is negative 10. If that was really a to the negative 10, what does that mean to do with the a? On the bottom. And when you put it on the bottom, it's no longer negative. And so this is really just a 1 up here. If there's nothing else there, we put a 1 there as kind of a placeholder. Now when I go to do the other side, now this is not negative, so I don't have to worry about any crazy fraction things. 5 to the power of 3 is 125. And then this would become a to the 3rd, b to the what? 6th. Okay, now I have to combine these two crazy things. Okay, but really all that's going to happen when I multiply that straight across, because this is over a 1 right now, and so all I'm going to do is combine these into one big fraction. So now that's going to say 125 a to the 3rd, b to the 6th, over 100 a to the 10th. Okay. 125 over 100, I would simplify that as a fraction. Like I would leave it as a fraction if at all possible, and that should be 5 over 4. Okay, so in my final answer, I would write 5 over 4. Oh, make that a little longer. How do I combine my a's? You subtract. So 3 minus 10 is negative 7. So what does that tell you about the a? Goes on the bottom, and it's going to have a 7 on it. And then my b just stays up on the top, so it'd be b to the 6th up on the top. So there's your final answer. Questions on that at all? Isabel, another one? Okay, go ahead.
On the same page, number 6, mainly like B.
Okay, number 6. Mainly A, you said?
Mainly B.
Oh, mainly B. Okay. So that notation, and I had quite a few of us who were a little bit confused about that notation, that's not the word rot. Okay, that's not the letter O. That's R of T of X. Okay, we always kind of wrote it like R of T of X. What that means is to take the T function and plug it into the R function. This was composite functions. So I want to take the T function, this, and put it in place of X over here. Okay, so that's going to look like this. Is that just a regular 4? Okay, 4, and then 6x minus 9 squared plus 5. Does that make sense? That I plugged this in place of x over here. That's what this notation is telling you to do, is take the entire t of x and plug it into the r of x function. Okay? Now, to evaluate this, this 6x minus 9 squared, you're going to have to FOIL that. Okay? And I'm not going to take the... Do you need to see me FOIL?
No. But for B, since it just says find the formula, is that the answer, or do we have to do all the steps to figure out what the x would equal?
You don't have to figure out what x would equal. I would simplify it. Okay? So I would, like, you know, FOIL, like 6x minus 9 times 6x minus 9. Whoops. Plus 5, and so you would FOIL these together, and then you would distribute the 4, and then you would add the 5, and then, so your final answer would be something x squared plus something x plus something, and that's what would go in there for B. Okay. Technically, if I just asked you for a formula, and it didn't say you had to simplify, technically this would be a right answer, but I think the way this one is worded on your exam is as a multiple choice, and then this is one of your choices as a simplified one. So you will have to know how to simplify. Okay? But if it were a short response and I just asked you for a formula, you could technically just give me that. Okay? What else we got? Lauren?
Page 11, number 10.
Page 11, number 10. Let's make sure. On the same page? Okay, sure. So we're doing number 3 and then remind me about that one, Lauren. Okay, so 81 over 16 to the power of negative 3/4. Technically, you could put this in your calculator. Your calculator is going to give you a decimal for this. I probably won't ask for your answer as a decimal. I'll probably want it as a fraction. If you know how to use your calculator to turn it back into a fraction, more power to you. But really what you're doing here is 81 to the power of 3/4. 81 to the power of 3/4, which is going to be 27. If you didn't know that, you could use your calculator. And then you're doing 16 to the power of 3/4, which is going to be 8, I believe. But again, if you don't believe me, you can use your calculator. And then what does this negative sign do to your answer? Flip it over, right? So the answer to this will go on the top, and the answer to this will go on the bottom of your final answer. So it's going to come out to be 8 over 27. Follow that, okay, Benny? Okay. Another thing, when you go to type in 81 to the power of 3/4, depending on your calculator, you may need to have that 3/4 in parentheses. Okay, if you got something other than 27 for that, you're going to need that in parentheses. And it never hurts to put it in parentheses. So if you're not sure, go ahead and put it in with parentheses. Okay. If you want to do that by hand, that's where you would do a factor tree and break 81 into like 4 pieces, and then take that one piece and raise it to the power of 3. But you shouldn't have to do that at this point. You should be able to just do it in your calculator. Okay, I remember page 11, number 10. Okay, so 1, 2, 3, 5, 6, 7, 8, 9. Of course, I didn't number mine. This one here? Is this the right page? Number 10?
Yeah.
Okay. All right, so we want to find the area of this rectangle. Well, how do you find area of a rectangle? Length times width, or base times height, right? So I'm really just doing this side times this side. And on this side, it's kind of confusing. That A, B, or the A and the D is just like the vertices, okay? So what would you call this length here? X plus 12, right? And then this length would be x plus y plus 8. So you're multiplying x plus 12 times x plus y plus 8. Okay? And then you're just distributing like crazy. So that would be an x squared. This would be an xy. This would be an 8x. This would be a 12x. Next one would be a 12y, and then 12 times 8 is 96. And in all of that, what's the only things that can combine? Yeah, I've got an 8x and a 12x that could combine to make a 20x. Everything else, your final answer is just going to be messy like this. Okay? What else would you like to see? Allison?
Can you do the top row of
On the same page? Sure. Okay. So this one here, what would that be? I guess number 8. I'm kind of cut off here in the corner, but number 8. There is one thing in here that you don't have to worry about for your exam, and that's that double root thing that it talks about. So first of all, the value of a sub 0, where did we say that always was located? This. That's the y-intercept, right? And kind of, I think they're trying to point you in the direction of this being 20. Okay? So the value of a sub 0 would be 20, okay? And then it wants an equation in factored form. Well, where do I get factors from? Okay, wherever the roots, right? Okay, so I have a root here, I have a root here, and I have a root here, okay? So if I have a root at -5, what does that mean my factor would look like? X plus 5. Yep, it's really x minus -5. So x plus 5 would be a factor there. Here my root is at -3. Okay, so my factor there would be x plus 3. And then here, this is a -1, so there my factor would be x plus 1. And this thing about a double root occurs when the graph is tangent to the axis. See how this is one of those ones where it just hits and then goes back up, it doesn't actually go through? Kind of mentioned this a couple times. This is not on your exam, okay? But that means that that's a double root, meaning that I have 2 copies of that. All right, I have 2 copies of that factor in my final expression. Okay, so my factored form, I'm just going to write this down here because it's big, would look like this. X plus 5 times x plus 3 times x plus 1, and I'd have 2 of that x plus 1. The x plus 1 would be squared. Okay, that's my factored form. Now, how do I get that to standard form? Allison?
Oh, I just have a question.
Sure.
Why is it squared?
This thing here is, and this is what I was saying, is not, there's nothing with double roots on your exam. But this told you that a double root occurs when the graph is tangent to the x-axis. Tangent means it just hits it and keeps going. It doesn't actually go through it. So see how right here, it like touches the, and of course I just scribbled all over it, but it just touches the axis. It doesn't actually go through it. Anywhere that happens on a graph, that's considered to be a double root. Like that root counts as 2 separate values. You just have the same value twice. It's kind of like when you have, no, that's a bad example. It's like when you do the quadratic formula and you get a 0 for the discriminant and you end up doing like 5 plus 0 and 5 minus 0 and you get the same answer either way, so you just say your answer is 5, okay? But technically you got that 2 different ways, so that counts as 2 separate roots. So that's what that's all about, is that this would tell me I have a double root, so I would square that, okay? Now how do I get from this to standard form for part C? Multiply it out. And again, I'm not going to take the time to FOIL it, but basically I would FOIL this out and then write this one out twice and FOIL it, and then take those 2 parentheses and multiply those together. It comes out to be huge. There's like 9 different terms, and then you can combine stuff. If you want to see the fully worked out version of that, it is on the answer key on my website. Okay, what it would look like if you put it all the way to standard form. But basically you just multiply it out. Okay. What else would you like to see from anywhere? Sarah?
7 on page 10.
Page 10, so flip back one page. Oops, went too far. Oh, I thought I announced to you guys to skip these. And I think I caught some people, but not others. Yeah, 6 and 7 on this page you do not have to do. That's that lesson at the end of chapter 11 that we skipped. Okay, so you got 6 and 7 on this page. This was chapter or page 10 in your packet. 6 and 7, you can skip those. Clarence?
On the front side of the last page, is 21.
Okay. Front side of the very last page.
Never mind.
No?
19 actually.
Okay.
One of the ones where you have to find the solution.
Okay. So, number 9. So, making sure I'm looking at the right one. No, I think not this night. Which page did you say?
19.
Page 19. Okay. Of course, I didn't number my pages, which would have been smart. What's your very last page? 22?
It's
2,
the one at the top that says just a little more.
19. Thank you. And my page is not. There it is. Okay. Except I don't see a 19 here. Before that?
Yeah,
Yeah,
it's
page
before
before
that.
that.
Okay, page before that.
Triangle at the top.
Yeah, it has a triangle at the top.
So page 6.
This one?
Yep.
This? Okay. Okay. What's my page number on this one, just so I can get a reference?
19.
This is page 19? Okay. Okay, and then you wanted really any of these that are find the solutions.
Yeah.
Okay, let's look at 27. So I want to get m by itself. So what do I do to get rid of a power of negative 4/3? Okay, just be careful with this. Yeah, you want to raise to the power of the reciprocal. Now over here on the left, these are going to cancel because you do multiply them. So that's why everybody always says multiply. But you just want to make sure that you're not multiplying over here. So over here you would do 625 to the power of negative 3/4. I would just put that in a calculator and then convert it back to a fraction at the end. I think it's going to be 1 over 125. Does that sound correct?
Does it have to be in fraction
It doesn't have to be, but I have a feeling if this was on a multiple choice section, that's how it would be written in the choices. Okay? So that's just one thing. If it doesn't specify and you have to give me the answer, I don't care. But if it's a multiple choice, you have to be comfortable with, like, if you get a decimal and the answers are in fractions, you want to be able to switch back and forth. You guys okay with switching back and forth between decimals and fractions? Okay. Okay. Yeah, I had a hard time finding it too. I think it was because I have my packet is just one-sided, so 22, 21. What is page 19? So it should be like the second page from the back. Okay, then you are missing some pages. Okay, I'll make sure to grab you another packet. We'll figure out what you're missing before you go. Okay. Anything else? What else would you like to go over? What's my time looking like? Got 10 minutes. Lauren?
Page 2, like 8 or 9.
8 or 9. Okay. Okay. So number 8 is asking, are these two things inverses of each other? And people went about this in a couple different ways. Some people like actually found the inverse of this one, and then they showed that, hey, the inverse of this one is this. And then they found the inverse of this one, and they said, hey, the inverse of this is this. That's fine. There was another way we talked about verifying that two things are inverses. Do you remember what that was? Okay, that's how you find an inverse. If I give you two things and I say test and tell me, are these two things inverses? Garrett, what do you do? Okay, so it's that. Yeah, that's another way. I hadn't even thought of that. But if you put a number in here for x, let's say 10, what would we get for y? What would we get for our p of x? 4, right? Then that means if I plug 4 in for x in the other problem, I should get 10 as an answer if these two things are inverses. So if I plug in a 4, do I get a 10 out for my answer? Yes. So since these two things are inverses of each other, that would be a way to tell that they're inverses. The rule that we learned is if you do the composition, which is like when you do the p of q or the q of p, if you plug one into the other, it should cancel out and just equal x. So if I take x minus 6 and plug it in right here for x, I'd get x minus 6 plus 6. Do you see that your 6's cancel and you're left with just x? And then that would happen if you did it the other way too, right? Q of p, if I did, x plus 6 minus 6, then those cancel and you're left with just x. So that's how, that's the official way to tell. But all those other methods are perfectly fine too. Those are all things that you know about inverses. But this is like the definition of an inverse. And then looking at number 9, I'll rewrite this down here. Y equals 6x minus 5. How do you turn something into an inverse? Like if I want the inverse of this, how do I find the inverse?
Flip the x and the y.
Good. Flip the x and the y. So x equals 6y minus 5. And then it wants it in slope-intercept form, so you would have to go back and solve this for y. So I would add the 5 to the other side. So I'd get x plus 5 equals 6y. And then, again, I want y by itself, so I would divide everything by 6. And I would end up writing this as y equals, this I would probably write as 1/6 x, okay, and then plus 5 over 6. That would be your inverse, okay? How can you tell on a graph if two things are inverses? Do you remember? What do the graphs do if they're inverses? Yep, it's the line y equals x, which goes right up the middle, kind of like that. So if this graph looks like this, then the inverse would look like that. Okay, they like flip over. Oh, you guys can't even see what I'm drawing. Sorry. If one graph looks like this straight up and down, then the other one's going to be kind of on its side over that line y equals x. Isabel?
Can we go back to page 11 and
Sure.
go in with the graph?
Okay.
It's like, I don't think I have to go through the whole problem of 9. I'm just wondering if you could like briefly explain how you would.
So this one, number 9.
Yeah.
Okay. Yeah, good question. So how would you get volume? So how do you get volume of any cube? It's length times width times height, and if it's a cube, what do you know? They're all going to be the same, right? If it's a cube, aren't your length, width, and height all the same? So this is saying that this is your length, width, and height. So you're really just doing x plus 3 times x plus 3 times x plus 3. This same question was on your last test, and I accepted it if you wrote it like this, or just like x plus 3 to the power of 3, or if you like multiplied it out and actually figured out what the simplified version of that was. I would take it either way. Okay? That's really all you have to do is take x plus 3 and cube it. Okay? Any others? Sarah?
Back on page 3, number 7.
3. Number 7. Okay. Okay. Oh, domain and range, our favorite questions. Okay, domain is asking me, what is x allowed to be? What kinds of numbers are allowed to be exponents? Anything, right? You can make a negative number, you can make a decimal, a fraction, whatever. Range is asking you, what kinds of answers can you get? If you take 6 and raise it to a power, what kind of answer are you always going to get? It's always going to be positive. It's going to be something bigger than 0. You can never have it actually equal 0. So this would be all real numbers greater than 0. And if that's too abstract for you to think about, if that's hard for you to think about that way, maybe look at this on a graph. Okay, you could plug that into your y equals and look at it on a graph and see where does it cross, where does it not cross. Okay, what areas of the graph does it avoid? Good? What else we got? What's our confidence level right now? Tell me 1 through 5. 5 is you could take the exam right now. Okay. All right. Those of you who are 3s and below, please put some time into this between now and Wednesday. Okay. Mr. Groheis will be here to answer questions at the beginning. He's taught this for years, so I have faith that he can go through it with you. And then at some point, he has to step out, but Mrs. Merritt will be stepping in. So Mrs. Merritt can help out too. I am here after school today and tomorrow if you want to come and work with me at all. And I will be available by text and email. And I also put the answer key up for both parts of the review. The whole thing should be up now. It is in 2 separate parts, so just make sure you check both files. The answer key's up there, and then I'll be posting this video and the video from 4th hour, okay, which we may have gone over other questions so that you can kind of double your question time, okay? And then this packet will be collected on the day of your exam.